Okay, so in this video, we're just going to do some exam question practice together. I've posted these exam questions on Show My Homework. The document is called Exam Questions, No Mark Scheme. So you need to have this in front of you. If you don't have a printer, don't worry about it. Just read it from your screen and write the answers on a piece of paper. I'm just going to give you one or two pointers before you start, and then I want you to pause me, answer the questions, and then press play again when you're ready to go through the answers. First few questions I think should be okay. Just with this one here, I just want to give you an idea of what you're supposed to include because it's a 6-mark question. So that they're asking you to design or describe an experiment comparing large marble chips with small marble chips. So when you're talking about large marble chips and small marble chips, you'll obviously have to talk about surface area, and you're going to have to talk about the frequency of collisions and talk about the rate of the reaction. But they're asking you to describe an investigation. So you need to say how you're going to do that investigation fairly. In other words, what are your controls going to be? What variables are you going to keep constant? So make sure you're talking about your controls as well as just the difference in the size of your marble chips. One of the other questions, stop it. This one here, number 7. So ignore the numbers because the numbers are all over the place. This one here is number 7. You just need to finish off the simple equation. They've told you what the products are, carbon dioxide and water. So you should know the formula for carbon dioxide and for water. You also need to write the formula for calcium chloride, okay? To do that, you need to go to your periodic table. What charge does calcium have when it forms an ion? What charge does chlorine have when it forms an ion? How many calciums and chlorines do you need so that the charge is balanced? You need to work out the formula of calcium chloride, but the other two should be self-explanatory. This one, even if you don't have it printed off, you should be able to read it from your screen. You're just going to calculate the gradient of that line by picking 2 different points. This one looks kind of like difficult. They're asking you about a catalyst. You should know that catalysts aren't used up during a reaction. So just using that piece of knowledge, they're not used up during a reaction. Pick which graph represents the mass of a catalyst over time. And that one you should be able to have a go at. So yeah, have a go with them. They are GCSE exam questions, but do your best, have a go, and then when you're ready, come back to this video and we're going to go through the answers. Okay, so hopefully you've had a go. I'm going to start going through the answers now. Using the graph, give the time in seconds at which the reaction stops. So the reaction stops where it starts to level out. And you do need to be quite precise with this. I need to get exactly the right moment that this graph starts to level out. So if I look at my x-axis, I'm going up in 2. So each box I'm going up in 2. So I'm going 62, 64, 66, 68, etc. And if you zoom right in, you will see that it's still increasing at 60. And it's kind of 62, 64, I would say it's finally stopped increasing. There's no increase. It's dead straight from 64 on. So on the mark scheme, it gives you an answer, gives you the mark for the answer between 64 and 66. Okay, it doesn't give you the answer for anything below 64. You really do have to be accurate. Give the reason why the reaction stopped. Okay, what does it say? It says that you're doing the reaction between magnesium and excess dilute hydrochloric acid. Excess means that you've got more than you need. So you've got more HCl than you need. That means that the HCl is not going to run out, but your magnesium will. So the reason it stops is because the magnesium has run out. If they hadn't told you something was in excess, you get the mark for saying that the reactions ran out. But because they've told you that hydrochloric acid was in excess, you need to specifically tell me that it's magnesium that has run out. Okay, I know that might seem a little bit harsh. Just make sure you're reading the question properly. Use the graph to calculate the average rate of reaction during the first 20 seconds. If I'm looking at the average rate in reaction, okay, and I appreciate this is hard to do if you don't have it in front of you, but you're going to 20 seconds on the x-axis because that's the time I'm concerned with. And at 20 seconds, is that right? 20 seconds, I am at 48 on the x-axis. So it started down here at 0. It's gone the whole way up to 48 after 20 seconds. So my change in concentration, don't freeze. Why are you doing this to me? My change in concentration is going to be 48, and it's taken 20 seconds. So 48 divided by 20 equals 2.4. And they've given you the unit as centimeters cubed per second. Okay. The rate of the reaction can be changed by adding a solid catalyst, which line shows how the volume of hydrogen produced and the mass of the catalyst change. So change in the final volume. If you add a catalyst, are you going to get more or less product? The answer is neither. If you add a catalyst, you are not going to change the amount of product you get. So I'm going to be looking at B and C. Then we're looking at the changes to the mass of the catalyst. Does the catalyst get used up during the reaction? The answer is no, which means my answer is going to be C. No change in the volume of hydrogen, no change in the mass of the catalyst. B, this is your 6-mark question, okay? So I'm going to go through the points that you would need to get a full 6 marks. So I'm going to just start by describing how I'm going to do this reaction, okay? They're telling you you're reacting calcium carbonate, which are marble chips, and an acid, and you are producing carbon dioxide. Remember, you're trying to compare the rates of the reactions. You need to be able to calculate the rate. So you need a way of recording how something is changing over time. Because I am producing a gas, there are 2 different methods you can use. You can describe the gas syringe method, or you can describe the mass balance method. I'm going to go for the gas syringe method. Okay, you're not going to be talking about disappear and cross. But you do need to mention how you're going to record the rate of a reaction, how you're going to record the change, and it's going to be over time. So I'm going to say, and when I'm doing this, the only thing I want to change between reactions is the size of the marble chips. Everything else is going to be the same. So I'm going to say, measure volume of HCl, okay, because I want to make that consistent each time. And I'm going to say, get mass of the calcium carbonate, because I'm going to change the size of the calcium carbonate chips, but I'm going to use the same mass each time. So they're going to be consistent. Mass of calcium carbonate, mix them together. Connect gas syringe to record volume of CO2, because that's the gas I'm producing. Volume of CO2 produced over time. Okay, so I am saying that I'm getting a specific volume of HCl, okay? I'm getting a specific mass of calcium carbonate, mixing them together, and I'm going to record this reaction by using a gas syringe over time. You can also talk about the mass balance. Mix together, connect the coordinates. Then you can change size of marble chips, keeping mass of the marble chips. Marble chips are just the calcium carbonate. Mass of marble chips constant, and specify, keep volume and concentration of HCl constant. You can talk about keeping temperature constant, about not using, well, they haven't told you anything about catalysts, don't talk about catalysts. Yeah, keep temperature constant, keep everything constant, apart from the size of the marble chips, and the results you're going to see, results should show you get a faster reaction with smaller chips, and then you're going to tell me why. Smaller chips, smaller chips have greater surface area. Don't abbreviate surface area to SA, I'm just being very lazy. Smaller chips have greater surface area, and you get more frequent collisions. Now, you don't need to have all of this for 6 marks, okay? This is me being quite thorough. But you do need to mention what you're keeping constant. You do need to mention how you're going to actually record the rate of the reaction. So mention gas syringe, mention mass balance, and mention that you're doing it over time. mention what you're keeping constant, and then mention the results that you're going to see, the difference in the rates between the big chips and the small chips, and then tell me why in terms of collisions. To stop this video becoming incredibly long, I am going to start another one, so go to the next video to get the rest of the answers for these questions.